Let's do this. Okay, you guys all got your papers? Y'all got a snack?
Yeah.
Let's go. We'll take a break in a little bit.
Is this the best?
Yeah, you can actually have a friend.
Okay, guys, so I don't know, I got this packet. I cut out like half the pages. I kind of tried to just keep in the stuff that I felt like was important, okay?
Are you kidding me? It's horizontal?
Yeah. What are you doing? You'll be alright.
I'm dropping it.
Alright. SOHCAHTOA, pretty sure everybody knows that, but our understanding of the unit circle kind of comes from that.
Oh, do the
What's
video.
up, Lynn? You want a snack? Alright then.
You should do the video of that teacher who's like,
No, we can't. We can't discuss that. Okay. One of the most important trig identities that we know comes from SOHCAHTOA, basically, okay? If I take this triangle, and we know that, you know, a squared plus b squared equals c squared, all right? And let's say I put this triangle on a unit circle, a circle with a center there, and a radius up to here, okay? I'm going to draw a unit circle. You guys ready? Hold on. Thank you. Thank you. Wait, no, not yet. It's the same picture.
I'm getting the vibes that you didn't draw it.
Yeah, I did shut up.
Did the teacher just tell me to shut up?
Yes. Okay, there we go. Hey, thank you. Now you get one. Okay, do you guys know why it's called a unit circle?
Because it moves stuff around and goes one unit.
Idiots, man. Because the radius is 1 unit. So it's a scaled down circle, basically, okay? It's a scaled down circle where the radius is 1. Now look, if the radius is 1 in SOHCAHTOA, sine just equals opposite over 1. Does that make sense? So this is the sine alpha part, okay? Cosine equals adjacent over 1. So this is only on the unit circle. We scale it down. This is the cosine part. And if this is centered at 0, 0, what is the coordinate of this point right here? Well, I'm going over A and up O, right? So what's the coordinate? Cosine, comma, sine. This is why the unit circle, and I'm going to teach you how to make it on your best friend chart, because you're going to have to be able to duplicate that on the AP test without, looking. Okay? This is why on the top I always write cosine, comma, sine. Okay? It's a little bit of a pain to remember. Cosine's the x-coordinate, sine's the y-coordinate. I mean, you could come back to this. I usually just remember, don't go crazy, because that lasts more than one session.
Oh. There will.
I have to remember that it's like in alphabetical order, or I remember it's opposite of the way you usually think of sine goes first, cosine, whatever. Okay? But that comes from SOHCAHTOA. Now, the next thing that's really important with this triangle, if I use the Pythagorean theorem right here, you guys, a squared plus b squared equals c squared, right? That is our first and greatest trig identity right there. Now, we are going to talk about some trig identities. We did a little bit of trig identities last year in honors, but not as much as I would have loved to spend like a month on trig identities. Okay, we're just running out of time. Say again. Yeah, that's an equation of a circle. And in fact, those of us in BC, and I don't think AB does polar, but polar coordinates is almost all based on this equation as well. Okay? So sine squared plus cosine squared is 1. Majorly important. Make sure that you guys know that. All right? A lot of different identities come from that. Okay, so it says, blah, 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 most points are on the unit circle, the point 0, 1. I just want you guys to look at this real quick. Did I put this page in here? I took some pages out because I was like, lame.
Wait,
No, I didn't put that page
real
in.
quick, Mitchell. What's that fish you've been drawing with the sign? You're drawing with the sign.
Oh, the fish?
Yeah.
You know what that is?
Yeah.
That's a Greek letter, alpha. Alpha. In trig, you'll use a lot of Greek letters. So we'll use, if you see this, these are the ones we use the most often. That's alpha. That's beta. That's theta, which we usually use for angles.
Delta.
That's delta. You guys have seen that before when we were doing that Euler's table, right? Delta y over delta x. So like that's why it's like dy dx. That's a Greek letter delta.
Omega?
Yeah, what does omega look like?
It's the W.
Yeah, omega. Yeah, we use that one for angular rotation. Anyway, Blah, blah, blah. Okay, Greek letters. Greek letters are fun. Okay, so here's the first part of our unit circle, right? This was the next page. All right? And what we're going to practice on that best friend chart that I gave you guys, but we'll practice this later, so don't fill it in just yet. Okay, over here now, this is a unit circle. Okay, don't forget to grab papers on Carly's desk. Papers, snacks, papers. All right? Oh, thanks, buddy. Unit circle.
That's why when sine is 0, cosine is 1 because they're not equating.
Yep. Yeah, that's true. And if you square root, it could be plus or minus 1, right?
Yeah.
Okay, so over 1, up 0, if I'm plotting points, that's the point. Over 0, up 1, that's the point. Negative 1, 0, that's the point. 0, negative 1. Okay? But it's just because it's on a unit circle. So think of this on a graph, and I'm going like over 1, up 0, or over 0, up 1. So I always start by drawing that on my unit circle. Okay? On the top, because I know cosine is the x and sine is the y, I just write cosine theta, comma, sine theta. And you can write like xy if you need to. There's regular pens and pencils in the back over there if you need. Those are kind of like markery. Okay? Okay, what else? Now we have 4 trig functions that you guys need to know, right? Our 4 trig functions, aside from just sine and cosine. Tangent. Now tangent can be represented in 2 different ways. It's sine over cosine, right? You definitely need to know that. And tangent is also the reciprocal of cotangent. I don't really use that much, but it is, okay? Cotangent's cosine over sine. Megan, snacks, papers. And it can also be represented as 1 over tangent. Now, do not get these confused with arctan or inverse tan.
Got it.
Inverse tan is not cotan. It's not the same thing, okay? These are inverse functions, and we are going to talk about that later on today. These are just a regular standard. These are called the quotient identities and the reciprocal identities, okay? These are your quotient identities. Tangent, sine over cosine, cotangent flips it, cosine over sine. These are the reciprocal identities. So you got to remember, secant 1 over cosine, cosecant is 1 over sine. Okay? Make sense?
Just move.
Boss, you want a snack? Hey, tell boss thank you for the snacks. He's the one who bought them for us. Thank you. Look at how many kids are here.
Microwave popcorn?
Yeah, we have microwave popcorn.
So is this for AP calculus?
Heck yeah,
It
boss.
is.
AV and VC, we're studying twice a week till the AP does.
How
Look at how
how
awesome
late
it
do you
is.
guys go tonight? 4:30?
5.
We don't leave.
5, maybe midnight. We're going to see how it goes. Okay?
No, I'm so down.
Boss, thanks for stopping by. I had to show him how many of you guys came so when he sees the food budget, he won't kill me. Thank you. All right. It's fine. It's all good. Okay, so you guys got to know now, those are our 6. And of course, you know that we use trig a lot because we've already memorized derivatives of sine, cosine, tangent, cotangent, secant, cosecant, right? We memorized all those derivatives. We're going to be memorizing integrals, okay, if we haven't memorized them yet, so all that. All right, does that make sense? The best friend chart that I gave you comes from this, which is actually kind of cool. I'll show you guys where it comes from, then maybe it'll help you remember, okay? So, talks about how you really do have to memorize, you have to know these angles, and you got to know them all the way around the unit circle, all right? But this is kind of cool, but then I'll show you how I write it in our best friend chart, okay? So what I do is along the top, I put the, like pi over 6, 30, pi over 4, 45. We'll fill ours out in a second, I'll show you how I do it. Pi over 3, 60. Now, I don't include those on the chart, but they follow the pattern, so it's actually kind of cool if we check it out right here, okay? Oh, thanks, guys. All right? This is a little weird. I don't really think about that. I mean, it's interesting, but it's a little weird, okay? Now, if you guys check this out, we know that the sine of pi over 6 is 1. Root 1 over 2, right? But watch this real quick. 0, 1, 2, 3, 4. Okay, check out how cool this is. If you follow this pattern, what's 0 over 2 if I reduce that? 0, and you know, and the sine of 0 is 0, okay? And then it's root 1 over 2, which is just a half. And then it's root 2 over 2, root 3 over 2. So this is what we have on our best friend chart. But then, what's the sign of 90? You guys know what the sign of 90 is?
1.
And look, it follows the pattern. Root 4 is 2 over 2, which is 1. So it follows this total pattern of square root 1, 0, 1, 2, 3, 4. And then cosine follows the same pattern of square root 4, 3, 2, 1, 0. Okay? Now, it's actually super, super interesting. Now, when we do our best friend chart, though, we're only going to do this, just because, right? The other parts, rather than going, oh, what's the square root of 0 over 2, I just go and look at this. And that's where my 1s and 0s come from, but it fits right into our pattern, which is kind of interesting. Okay? So, you start by, did I put this page in there? No, I did not. Okay. You start by doing that and then just simplifying it. It becomes 0, 1 over 2, root 2 over 2, root 3 over 2, 1, and then backwards. All right? Again, these are the ones that I put in the best friend chart. If you want to fill it in right now or to test yourself later on that, you can. But basically, here's how it works. Okay? Now, when you guys are on your, so look at the paper I gave you that's like blue? Yeah, blue.
Yeah, blue.
Okay. When you're on your AP test, I'm not going to be able to hand you this little blue paper to fill in. I know it's very sad. I'm not even allowed to walk within like 100 feet of where you guys are testing or something.
I believe in you. You've got it.
I cannot. Okay, so we make this little table. It's like a 3 by 3. This is what you do, just straight, like just you can write this down somewhere. If you're just making it by yourself, okay? And along the side, you write the trig functions in the order that you see them on the calculator, right? Like sine, cosine, tangent. So I write them in order. As that. When we start doing practice AP tests, I'll have you guys start memorizing these, okay? Like not letting you use your best friend chart, but you have to recreate it. Then I write them in order, and this is why I go with degrees first, because it's a little easier for me to put whole numbers in order than fractions, right? 30, 45, 60. And then next to it I convert it, and 30 I know is pi over 6, right? 45 is pi over 4, 60 is pi over 3. So that's the setup of it. Now you already have that on your paper, but again, if I were to go sit down and do the AP test, I don't know if they give you scratch paper or whatever, but I'd write it on something that I could go back and refer to every single time. The first time I get a trig question, I'd write it so that I can see it, okay? And then we go like this. As my trig teacher taught me 20 years ago, trig is as easy as 1, 2, 3. Okay? So we follow that pattern, right? And then you just got to fill it in. So you say to yourself, trig is as easy as 1, 2, 3. You fill this in. This is 1 over 2, root 2 over 2, root 3 over 2. And it is square root 1 over 2, but square root of 1 is 1, so we're fine. And then what do we do on the cosine part? 3, 2, 1. 3 over 2, 2 over 2, 1 over 2. And then I like to put the tangent on there. Now we know from before that tangent is sine over cosine, right? Tangent is sine over cosine. Okay. I want you guys to divide 1/2 by root 3 over 2. Now if we were doing this the long way, right? I'd be like this. I'd be like, okay, 1/2 divided by root 3 over 2. But when I'm dividing fractions, what am I really doing? Multiplying by the reciprocal. So what do I get? 1 over root 3. Okay? The easy way to do it, if I'm dividing the 2 on the bottom here and the 2 on the bottom are going to cancel. So what am I going to get? 1 over root 3. That's the easy way to do it. So you just look and say, I know that's 1 over root 3. And then over here, if the 2's cancel, what's square root 2 over square root 2? 1. So I know that's 1. And then over here, what's square root 3 over 1? Square root 3. Okay. Now, the only...
Coach Levin, if you're still in the building, please contact the main office at 755. Coach Levin, if you are in the building, contact the main office, 755.
The only other thing that I write on here, you guys, is on this one. On that one, I radicalize it just because it's the only one that's not radicalized. Now, do we have to rationalize them? Do we have to rationalize denominators on the AP test? Heck no. If it's a multiple choice question, maybe, right? So you got to know how to do it. You have to know how to rationalize. And basically the way I change this is I go like this. If it's like 1 over square root 3, okay, I multiply by root 3 on the top and bottom. Root 3 over 3. Okay, so you might see it come up more that way. You might see it come up that way. It doesn't really matter. All right, so I usually write that in my first box, and I just do that. Okay, make sense? Okay, so let's go back over to here now. And so here is, I really cut out a lot of pages because Dallin stressed me out last week and told me I was killing trees.
I said go for it.
You told me I was killing trees.
Yeah,
All right,
Yeah, burn the
that's our next page. Here we go.
Don't cut me.
Okay. Now, we know this is our first quadrant. I didn't include this page in there, but you guys can see it from the table, okay? So my first quadrant, sine was 1 over root 2, root 2 over 2, root 3 over 2. That was sine. Cosine, root 3 over 2, root 2 over 2, 1 over 2. All right? So how do we move beyond?
I put all of those on the outside.
Oh, you're fine. I don't care. So how do we move beyond that? Okay, guys, we got to talk about some of this stuff. Most of what we're doing in calculus is in radians. All right?
We love radians.
We do love radians. In radians, all the way around, I'm going to label this 0, and all the way around is 2 pi. Okay? I never use that. All right. And I don't use that either. We're going to use this differently. Not yet. We're back to the pink paper on page 10, which is really page 4, because I wrote down a bunch of pages. No, we're actually on page 8.
I remember finding it that I wasn't going to like radians, and now they're the best thing ever.
All right, thank you. That is a testament to how much I know. All right. Dallin said, he remembers last year in honors math, I said, you guys are going to hate radians when I first show it to you, and then it's all you're ever going to want to use. And guess what? It's all we ever want to use. Right? It's just like you hate it, and then you just love it. Okay, so here's how it goes. 2 pi is all the way around, which means pi is over here. And I know that this is pi over 2, and this is 3 pi over 2. Okay? Now, when you go to find angles in the different quadrants, here's how you have to do it, okay? In the first quadrant, it's just theta. So pi over 3, pi over 4, pi over 6 in the first quadrant is just pi over 3, pi over 4, pi over 6. I would erase that. I don't care about that. That's weird. Okay, so don't worry about that. It's literally just whatever theta is in the first quadrant is itself. All right? Now, when we move into the second quadrant, theta is like this reference angle right here. So, for example, let's talk about this with pi over 6. If I were to put a pi over 6 right here, if I do pi and I back up pi over 6, if I do pi minus pi over 6, what angle would that be? 5 pi over 6. That's how we're finding those angles, right? If this were pi over 4, and now we're backing that up from pi, what would it be? Because you think of this as, this is how you do it. 4 pi over 4 minus pi over 4 is 3 pi over 4. Make sense? Okay, so in the second quadrant, you always take it away from pi. All right? In the third quadrant, you guys, we add it to pi. I don't know why it says theta plus pi instead of pi plus theta. It doesn't really matter. But basically, let's say that this right here was pi over 3. So if I go, what's pi plus pi over 3? Remember that that's 3 over 3 plus 1 over 3. And my new one would be 4 pi over 3. Make sense? So that's how we find it in the third quadrant. And then how we find our angles in the last quadrant, erase that because, well, actually don't erase that, we'll talk about it. Okay, in the final quadrant, it's actually 2 pi minus. That's where we get this from. 2 pi minus, okay? And 2 pi we use like, let's pick one, pi over 3, 4, 6. Let's use pi over 4. Let's say my reference angle, this is called a reference angle. Let's say my reference angle is pi over 4. Okay, what would 2 pi be in pi over 4? So what would 2 pi be?
8 pi over
8 pi over 4, right? Because we're over 4. And 8, and go back 1, 8 minus 1 is 7 pi over 4. So I would call this 7 pi over 4. Now, the only time that you have to be very careful about this is when we're doing something called inverse trig functions, okay? Which we'll get to, which is inverse sine, inverse cosine, inverse tangent. And the problem with those is that they're only defined in certain quadrants, so we'll talk about that. But if we're doing inverse trig functions, we actually, for sine and tangent, call it negative pi over 4. We don't call it 7 pi over 4, okay? Now, those are the exact same angle. 7 pi over 4 and negative pi over 4 are the exact same thing. But if you're working with a problem that has like, what's the arctan of -1? Okay, and we'll get to this in a minute, but what's the arctan of -1? That would be your answer, right? But if I'm working with a trig equation, I'm trying to solve it, and it says, where does tangent equal 1 on the interval 0 to 2 pi? That would be your answer, okay? So we're going to kind of talk about that, but do you guys understand how to move around the unit circle? And you always measure from the pi's. You don't measure from the pi over 2 or from the 3 pi over 2. We just know those are there. We always measure here because it makes like a little bow tie in a triangle. They always measure down to here for our triangles. Okay? You never measure your triangle over. You shouldn't do that. All right? So, here we go. Ooh, that's so fun. Nope, I took that out. All right. Now, I left this page in here. If you want to do it, you can, for sure. I left this page in here. We can fill out. A lot of trig teachers are going to teach you to fill out a unit circle, okay? I'm not going to teach you to fill out a unit circle because I think that's garbage. That's way too much memorizing. But at least you can see.
You made us do that last year.
I know. Well, I made you do it, but not memorize it. At least you guys can see. This is important, though, all right? Okay, look, let me color code this. You ready? The one on the bottom is pi over 6, which means that one is also pi over 6. That one's pi over 6, and that one's pi over 6. You guys see that? Okay, so think about this real quick. It's pi over 6 is my reference angle, so here it's called pi over 6. What's pi minus pi over 6? So we think of that as 6 over 6, minus 1 is 5. That's why that's 5 pi over 6, okay? What's pi plus pi over 6? 7, because it's 6 plus 1. All right? And then over here, it's 2 pi minus. What's 2 pi minus pi over 6? Well, 2 pi is 12 over 6 minus 1 is 11 over 6. Okay? Now, these are called reference angles. And so the way it works is like, okay, if here I go over root 3 over 2 and up at 1/2, I'm also going over root 3 over 2 and up 1/2. The only difference is I'm going left and then up, right? Negative and then positive. Does that make sense? So I'm going left, up.
No, it should make sense.
Yeah, and then down here, how am I getting, it's still root 3 over 2 1/2, because it's all based off of pi over 6, but how am I getting those? I'm going left, down, negative, negative.
Oh, why didn't you teach it like this last year? Makes
I don't know, man. I do the best I can, you know,
I
Dom?
know. We gotta
Sometimes I teach good, sometimes I
the fact
just
that you're
teach like
teaching us it now,
crap.
that's
You're
enough.
learning.
Okay.
You're learning as a teacher.
I explain things sometimes 20 different ways and it sticks differently. Okay, look, now, if I go to the right and down, that's root 3 over 2, 1/2, that goes positive, negative. Okay? Because coordinates in the first quadrant will go positive, positive. Coordinates in the second quadrant will go negative, positive. In the third quadrant are negative, negative, and the fourth are positive, negative. So it's just these same coordinates repeated with following these. Do you guys understand why this is, why did that not do what? Positive. There. Okay, do you guys understand what I mean by negative, positive? Left, up. Negative, negative, left, down. Positive, negative, right, down. Okay?
I get it now.
Yeah, exactly. It's exactly like a normal, like, trig, like a normal coordinate plane, like a normal system, right? Okay, now look.
Why didn't you tell us that last year?
I don't know, because I suck.
No, you did tell us that last year.
Thank you. I'm pretty sure I did.
I remember.
Why didn't you listen to me
Why
last
didn't you
year?
tell me any of this at all?
So much more.
Yeah, you guys have like a year on your last year's jobs. Okay. Okay, guys, look. The pi over 3s. So the way I remember this, if you remember the first quadrant and like pi over 6 comes first, the ones closest to this axis are pi over 6. The ones closest to this axis are pi over 3. Okay? So if they're closer down here, they're pi over 6. If they're closer up here, they're pi over 3. All right? Now, check it out, guys. This one, all the numbers are 1/2 root 3 over 2. Okay, Dom, did you feel these all right? 1/2 root 3 over 2. 1/2 root 3 over 2. Now, go fill in the negatives where you think they're going to go.
All right.
Go fill in the negatives, okay?
There's like an extra box. Oh, that's gonna do it wrong.
It's so easy to figure out what's negative or not. Just use the classic acronym. All.
No, it's. There's an acronym. Yeah.
Okay, so
Tavish. I know it's
in the second quadrant, it goes negative, positive. In the third quadrant, it's negative, negative. In the fourth quadrant, it goes over, down. It goes positive, negative. Make sense?
Wait,
Okay.
It does make sense.
wait. So
Okay.
now I know the positive, negative stuff. How do you know exactly what?
Are you talking about the ratios or the degrees? The ratios, you memorize that from the chart because you go, if you can get the first quadrant, you can get everything. Sine is 1, 2, 3, cosine is 3, 2, 1. Okay? And sine is the y coordinate, cosine is the x. So 1, 2, 3, 3, 2, 1.
That makes sense.
Okay, beautiful. Okay, so now, I'm such a better teacher than I was last year. Incredible. All right.
I know, I actually understand it this time.
Funny.
No, I understood like everything you taught last year except the trigonometry.
Well, we were also rushing, and I was also.
I feel like we're rushing more this year.
You,
Well, yeah, because it's freaking calculus.
you actually taught on like
Oh yeah.
Look at me, Miss Mitchell. I already did 2 of them. I'll do the pink packet at home. Can I count this as credit though?
Half, yeah. All right. So, look, guys. These are all going to be root 2 over 2.
I need extra credit, bro.
Every time you come is extra credit. If you're not here, you have to turn in the value.
You know
Here,
I'm
I
here
assume you're
every
going
time,
wrong. I know. Okay, here we go, guys. So 3 pi over 4 negative positive. 5 pi over 4 negative negative. 7 pi over 4 positive negative. Are we good? Does that make sense?
Hold up.
Okay, now, if you like doing it that way and saying, okay, I like knowing that in the second quadrant, it's negative positive, which means cosine's negative, sine's positive. Do it that way, that's fabulous, okay? The way that I do it is this. You guys ready?
I am ready.
All right, we go.
This is so watering.
A, S, T, C.
All Asians. You want to say
All students.
No, I'm
All-
pretty sure that was Tavish.
No, I told it to him last year.
You did?
Yes.
Mitchell has a racist phrase.
I absolutely do not.
You need to get permission from Mr. Fired.
All students take calculus. Recording's on. All right? Now, guys, what does this actually mean? All trig functions are positive in quadrant 1.
Mitchell said.
Because,
I'm gonna say him.
Okay, you told Zach and not me.
okay, I'll tell you later. I'll tell you when you're older. If it's in quadrant 1, sine and cosine are both positive, and what's a positive divided by a positive? A positive.
That is so.
Okay.
From.
If it's in quadrant 2,
Very offended.
it goes negative positive, right? So cosine is the x coordinate, cosine is negative, sine is positive. And you guys, what's a negative divided by a positive? A negative, so tangent is also negative here, because it's a negative divided by a positive. So sine is the only one that's positive. The other two are negative.
Whoa.
Now, in the third quadrant,
Tangent.
no snacks. They're calculus money. Get out of here. If I give them to you, I gotta give them to everybody. I love you terribly, though. Get out of here.
Just us.
No. Come here. I love you. No. No? I got you a treat. When?
Like a while ago.
Nope. Get out of here. Bring the drink next time. These are old. Oh. I bought this with AP money. I can't give it to you. Get out of here. I did. All right. It's not kind of not how it works. Okay. Guys, sine and cosine are both negative. But what's a negative divided by a negative?
Positive.
let's go. So only tan is positive because the other ones are negative. Does this like make sense? And over here, the x coordinate is positive, so cosine is positive, sine's negative, and when I divide them, tangent's negative. So only cosine is positive.
I love how you believe that way.
I wrote my coordinates as x and y-x instead. I did sine, comma, cosine.
I know, I do that all the time, which is why literally. Okay, I write on the top cosine, comma, sine. To remember that cosine is the x and sine is the y, because I screwed up.
I literally wrote sine, comma, crap.
Yeah.
Okay, that's gonna give me a 1 on the AP test. Someone makes that up.
Oh, it's gonna screw you up for sure.
I'm gonna get a 0 on the AP test.
No, you're not.
Yeah, get it.
Well, you get a 1 for right.
Okay.
Is it possible to get 0?
I think so.
What we're gonna do is, for just a minute, okay, because I'm gonna skip around a little bit, turn to the very last page. Some of you guys will recognize this because we did this.
Oh, I did this.
That was last year.
I don't
Okay, you guys, now I'm going to show you, you can get really fast at this. And if, once you make your little best friend chart, right, and you have to evaluate anything, after today, no matter what I give you, you need to be able to evaluate it and like quickly. Degrees, radians, positive, negative, I don't care. It's the last page.
I'm not sure what's the sign of 117.5. You said we gotta know all of it.
All of the special angles, buddy. Okay,
Easy.
let's go down the first quadrant. Okay, and I will teach you guys exactly how to do this, right? Okay, step 1, draw it. Last page of the big packet, last page.
Last page already.
Okay? And I need you guys to put this in the angle it goes with, in the quadrant it goes in. 5 pi over 6.
1 over secant.
What quadrant? Last page, Chris, very last page of the big packet.
Is it the last quadrant? Because it's right before.
That one, because it's right before pi, right? Okay, guys, we'll go through these a little bit slow and then we'll pick up the speed. You ready? Okay, this is pi. 5 pi over 6 is just less than pi, because that's 6 over 6, right? So you draw it there. Good so far? Okay, guys, cosecant is sine. Now look at that and go tell me what's the sine of pi over 6 off your best friend chart.
The sign.
1/2. So cosecant is
2. Wait,
2.
wait, what? Yeah,
A S quadrant sine is positive. That's it.
I forgot to flip it.
Okay, we'll do a bunch more.
Is it bad that I'm wrong?
Bro, I haven't, yeah, I was gonna say.
Why does it say what?
Why is it?
Because, okay, remember?
Isn't that just 1 over sine?
Yeah.
So then why?
Okay, so if I asked you to do what's the sine of 5 pi over 6, it would be 1/2 and it would be positive. Cosecant's 1 over sine. What's 1 over 1/2? 2. Just look at it.
Why is it 1 over 1?
Because of this right here. Yeah. What's 1/2 flip? Yeah, you flip it.
Help her in the fourth head, make her bleed out.
Chris,
Try again.
right?
What's
Right, easy. Hey. Chris, look.
That was better.
We got it.
We gotta know all of these. And cosecant is the reciprocal of sine. Chris, cosecant's reciprocal of sine.
Yes. Cosecant is reciprocal sine.
Okay? So over here, I found the sine, which was 1/2, so the cosecant is 2.
Okay. Yep.
Okay. All right. Now we're going to do some degrees also. Degrees are a little bit annoying. Instead of 0 and pi, we're measuring from 0 and 180, right? And guys, a negative angle goes backwards, past 180. Now, how far past 180 does 210 go?
30.
30. Look at your best friend chart. What's the sign of 30?
1 over 6. Wait. Yeah.
1/2. Chris, you're gonna be staying after to help me clean up trash, right?
This is not my fault.
Okay. A, guys, that one. AS. In the S quadrant, that's positive. You guys get it? Okay, 150, again, we're measuring 0, 180, and since it's negative, I gotta go backwards. So I'm going backwards, but this time I'm stopping before 180, right? This is backwards. If I'm stopping before 180, how much before am I stopping? 30.
Secant is 1 over
Yep.
cosine.
Alright, hold on.
Is
Okay, now,
3 over 2.
secant needs to go with cosine. So guys, here's the steps. What is the cosine of 30? What's the cosine of 30? That's from your chart. Root 3 over 2. Flip it, because it's a reciprocal. And then look, AST in the tangent quadrant, it's negative.
That's because we learned it.
Okay? Make sense?
Can we take some time to try?
Oh, I forgot it was.
Yes, but let me do 3 more, and then you're gonna try some on your own, or 2 more maybe. Okay. Whenever you guys are doing pi over 2, 3 pi over 2, 0, okay? On the axis, we do it differently, and you use that part of your best friend chart, okay? Whenever we're working on an axis. All right? So in degrees, this is 0, 90, 180, 270, 360. In radians, this is 0, pi over 2 pi, 3 pi over 2, 2 pi. Okay? We always use the 1s and 0s. So here's how I would do this, okay? If I'm like looking at my chart or whatever. All right, just go like this, okay? Cosecant is, pi is right there. What coordinate point is that, guys? Negative 1, 0. And it goes cosine, comma, sine. So the sine of pi is 0, right? What's the cosecant of pi? 1 over 0 undefined. Because it's 1 over 0 and it's because of the reciprocal function. Okay? Okay, for this one, 3 pi over 2 is down here. What coordinate point is that? 0, negative 1. That's cosine, that's sine. Now, I could go figure out tangent and reciprocal it, but you guys, cotangent is just cosine over sine, right?
0.
So cosine's cosine over sine, cosine over sine. This is 0 over negative 1, so that's 0. So that's how we find them at the coordinates, is we use like 1s and 0s. Pi over 2 is up here.
Wait, I thought
So it's 1.
Oh wait, tangent is sine over cosine.
Yeah, so cotangent is cosine over sine. Because on the end
Wait,
points,
that was tangent, would it be undefined?
correct. So that's cosine, comma, sine. Cosecant is 1 over sine. So it's 1 over 1, so that's 1. Make sense? Okay, let's see if you guys can do those. Okay? 7 through 13. Let's go. And then we'll keep coming back and practicing.
Like that. That just is sine of pi over 6. Which is sine of pi over 6 right there. And no, that's a square root 3 over 2. Right. Sine of pi over 6.
Okay, so it's
It's
all the way over
One out.
It's right here, right?
She's on sine 30.
Yeah.
Oh, yeah. the
Sine
backwards.
is,
Yeah, backwards.
sine is,
Wait, so
whiteboard. You did it backwards. You should fix that. Or you learn it backwards.
what's that?
The low one is 1/2.
No, now that I got this, how do I know what?
Teach good. Make it go.
What? 7 is
30.
1.
So you go. And then you get the line. So that's the angle. That angle is 30. Then you look at your square root of 3. You look at what third degree is in sine.
Sine pi over 3.
And then you look at
Square root of 3 over 2.
yeah, I think that's it. If I'm doing it
Oh,
wrong,
we have a
it's
shading method?
both done.
I don't understand what the all positive stuff was. Is this the one?
Okay, so I need to learn communication.
Ask me specifically. In the novel, the Great Gatsby, what is the color of the light that Gatsby sees at the end of the movie? I'm like, I just wrote an essay about this last time.
Backwards, past 180 into quadrant 2, yeah.
Wait, so pi over
Right. Right. It just changes the quadrant.
so pi over 3 would be
I think so. Yeah, I think it's one over
Pi over 3.
right there.
If it's 0 for 0, is it undefined or is it 0?
60 degrees.
It should never be 0 over 0 on trig stuff.
39?
0 for 0. Is that a locale?
Square root 3.
No, secant is a reciprocal of cosine, so it's 1 over 0, which is undefined. But it's just not 0 over 0. Then to down to.
I am here.
This is
Why didn't Garrett come? Ray, why didn't Garrett come? I know I saw Landon.
This is like my fourth batch.
Abby Nelson, is that you underneath that hat? Nope, that's Scout underneath that hat. Where's Abby Nelson? I swear I saw her.
She has work.
Ooh, okay. Make sure. Jacob and Abby Stone? Oh, hi. Oh, you're right up front. You sit over there. Okay. All right. Carolyn? Elena? No?
Where did you go?
Isaac? No. Delano? No. Ron?
I have to leave. I think
Where
Where are they?
Tell me what's happening.
Okay.
Yes,
Why is this positive?
He's trying to get his license.
He literally says,
Oh, yes.
I'm getting my license now, I'm roading. I'm like, no, that's not how it works. Okay.
I'm still now. I just sketched out. That's when I asked.
Yeah.
Don't give me a right home. What time do you do the thing? Yeah.
Right?
Oh, it's 10.
Cosine of power.
So then
Okay.
there. So
And yeah, that's just where.
So it's just 2.
That's 1 over.
Positive
Wait,
2.
secant the reciprocal. And it's pi over 3.
That's 2 square root 3.
Yeah.
I think.
Cosine, you're number 9. And then
Yeah.
1 over cosine. Cosine.
What's cosine pi over 3?
Oh, I brought it backwards again.
Dallin!
This is bad. We gotta fix it.
Throw
We gotta
that
fix
away.
this. We gotta fix this, bro. I'm gonna get every single question wrong.
Yeah, and you're going to get a 0 on the AP guess.
I'm gonna get a -1.
Negative.
I'm gonna get it so wrong that they're gonna hire a hitman just to kill me.
Wait, I need to check my
You know we're stingy like that. That will be the day.
The Roth styles are going to come out.
Okay? We'll practice more in a minute, but I'm way more concerned that you're able to get the radian ones too.
So that's
That's-
80, so it's just 30 over.
I think exclusively, well,
then that is-
most of what we're gonna do is gonna be radians.
Can you do 10 and 11?
I'm trying to think of a case where
Can you do
counters
10
up
again? Abby. Can you do 10 again?
Yeah,
Can you do 10 and 11?
yeah. So for 10, I did
I mean, the way we do it is just
negative 210, which is 30, and sine of 30 is a half, so go to secant it, oh. Dallin, darn you.
Wait, is it right?
No, that was
Yeah, no, it is.
Okay,
Because it's the reciprocal of sine.
That's what I get for trying to do it in my head. Let this be a lesson to you, Dallin. Don't do it in your head, because even I do it in my head. and I jack it
I can do
up.
it in my head. The problem is this whole thing's backwards, so I do it all wrong.
That's pretty funny. 60.
I'm literally just doing the paper in my head.
If you did credit, it would look great.
Yeah. So it's just.
And 13 is negative root 3 over 2.
We don't care about negatives and positives. Those are easy. Here, let's see.
Most definitely do care about them. That's the most number one thing people miss.
That's the easiest.
It's 30 away from that. So just which is square root 2.
Okay, so let's move on. If you want more practice, we will do more practice. So let's move on for a little bit.
Wait. Go back. What's 12?
Negative root 3 over 2.
Why is it negative?
Because it's in quadrant 2, and in quadrant 2, cosine is negative because AS. Sine's positive, cosine's negative.
Okay, I understand.
Down, I got it.
We will definitely practice more in a few minutes.
So what? You got
Why do you have so many food snacks? Where did she get a banana?
Hey, are we going to go through that entire box of fruit snacks just today?
Yes, we are.
Why do you like fruit snacks so much?
No, I just like food. I'll eat
Dallin, you were hiding. I've liberated it.
What?
Dude, that was good. That means you get more. You want
Hey, we haven't even got to the fun stuff yet. Let's go.
What page am I on?
Wait, that was not the fun stuff?
I'm writing them backwards again.
Hey, I know them in my head. I can't touch this. I know them in my head.
You're so...
No, because I'm writing it down sine, comma, cosine, and not cosine, comma, sine. Even though I know that sine is equal to y.
Okay, we're on this. It says page 11 is what one we're on, okay?
That's a W.
We don't really need this stuff a lot in Calc. I don't think we've run it yet.
We will get to it.
Oh, and
Okay.
polar equations unit?
Oh, yeah. Okay, so guys, we're going to talk about identities real quick. There is a ton of identities that come from sine squared plus cosine squared equals 1. I don't know what this homie is worried about with us putting the square there instead of there.
No.
Doesn't want to go
Bro, Mitchell, you have seen that be messed up. Don't you act?
No, I have, but he says the confusing convention of writing that. That's
It kind of is,
all right.
though. It confuses
Okay, guys, listen.
She can't even graduate high school in college.
What is this? That is not true. Hold on a second. Okay.
More than 10. I'll do like a 4.
That's the dumbest thing. 1 plus tangent plus 1, that's just plus 2.
I just don't. No, that's a typo. That's a typo.
Okay.
Just like that.
These are not derivatives, by the way. These are identities. Don't get that mixed up. All right. Check it out, guys. Take this.
Sine is plus or minus the square root of 1 minus
Now, you don't have to memorize all of these. We don't have to memorize any of these, really. Okay? Take that top one. Divide each term, just in your head is fine, by sine squared. What do you get? Divide each term by sine squared.
What page are you on?
11, 12.
Why am I pages upside down?
Cos squared equals 1 plus cos.
1 plus. Okay, guys, look. I'm dividing each of these by sine squared.
I mean, you said
That a division?
so would it be y?
Just trust me.
Does that mean tangent equals 1 over sine?
1 plus
Already cos.
cotangent squared equals what? Cosecant squared.
Okay, that's true.
I divided everything by sine squared and I came up with a new identity, which is down here. Cotangent squared is cosecant squared minus 1. They moved the 1 over, but whatever. Okay? Okay. Now, take that same thing, guys. Divide everything by cosine squared. What's sine squared divided by cosine squared?
Why did you write divided by but then also squared? Oh,
What's that divided by cosine squared? What's that divided by cosine squared?
I mean, secant squared.
Okay? So these are known together, if I take these are known as the Pythagorean identities. Do you have to memorize all three of them? Obviously not. Because if you know that one, you can just divide everything by sine squared or cosine squared to get the other ones. Okay? Make sense?
Oh, the sign one.
And then this is just like solving them differently or whatever.
The sign one actually makes sense, just knowing the numbers always add up to 2, 1.
Yeah, so it's plus or minus square root. Yeah. Okay? Are you guys okay with these identities? Okay, not like super important, but there they are. That I skipped. Double angle identities. If anybody has a photographic memory, just stick this in there. If you don't, then that's okay. Very unlikely that you will use these in calculus, but it is possible. Unlikely.
What are beta and alpha?
I skipped this page because you don't need to know it, but basically, you start with the sum and angle difference formulas, which I could derive those for you. And then, like, if it's sine alpha plus alpha to get sine 2 alpha, these are both just alphas. So it's like a whole thing. I'd have to teach you a whole lesson.
We don't need to know it.
No. Okay. Double angle formula for sine. Every once in a while you might see that. So I would like just remind you of it, but I don't feel like it's important enough to memorize, but here it is. Sine 2 theta is 2 sine cosine. Cosine 2 theta has 3 different identities. Any of them work. Okay? Those in turn lead to this, which in turn leads to this, which in turn leads to half angle formulas. There's one integral that you need a half angle formula to solve. Nobody's going to memorize this stuff, but if you want to memorize it, you can.
I cannot memorize those. I can like.
If we were in a trig class, I'd make you memorize all of it.
But we're not.
Okay? Hang on.
That's literally just saying the other thing, where sine of A equals 1 minus cosine of A. But then divided by 2, divide the other side.
Think of all the easy people how much they cost and how much they actually.
Yeah, those are completely identical. I'm just saying if you divide the left by 2, you go right by 2.
Okay. So, there's like one integral. I'm just doing this for you in case you ever go take college calculus or whatever. There's one integral that you have to use the half angle formula for. Like it's like cosine squared.
Where's the ice?
It's something like that. You have to know all your identities to be able to do
So you
that.
can bring the little 2 up top and say it's a square, so it's really just.
So you do basic things so you can solve.
That's identical together.
Okay, identities are not huge. Inverse trig functions are incredibly important. So can we talk about inverse trig real quick? All right, here we go. Inverse sine or arc sine. We have inverse cosine or arc cosine, and there's also inverse tangent or arc tangent. So I left this page in here so you can look at that, and so it would remind me to talk about it. Here we go. Inverse sine.
1 over square root.
Okay, real quick. I think this will help you. This helps me understand it, guys. Look. Okay, do you agree with me that that's the equation, y equals sine x?
Sure.
And the inverse is switching x and y. Now, you would not be able to graph that inverse on your graphing calculator because what?
It's not a function.
It's not a function. But I can do it on here because decimals is awesome. And that's the inverse. It's like sine, but it goes like that, right? So technically, that's the graph of inverse sine. But you guys, that is not a function. You understand that?
Yes.
Because the second that this loops around on top of this, it's not a function. So we have to restrict it so that it's a function. And here's how you restrict it. You say, okay, I have to erase everything up here, maybe to like right there, and I have to erase everything to here. Okay? And now it's a function, because the second it comes around right there, it's not anymore. So you guys see that?
Wait, so this is the graph of arc sine?
This is the graph of arc sine without all this stuff. Yeah, so look, I think it'll let me graph it on here. Why? Hopefully. Will let me graph arc sine? Oh, let's go. Okay, look.
I think you just type arc sine.
You guys see that? Do you see the part that it like highlighted there? Alright, I'll make it thick. Hold on. I'll make it thick with 3 C's. Hold on.
Is that illegal?
For real.
See that? That's arc sine. Okay? So if I turn this off, the graph of arc sine is that little boop. That's it. Alright? You guys, it's only defined from that point to that point. Okay, you guys see the bottom point? What bottom point is it defined at?
-1, -2.
Right? Because it's like 1 pi over 2, and it's defined at that point.
So the red
1 pi
side
over 2.
would be.
Okay, so look. For arc sine, this is what you have to remember. Okay, it's defined on the interval. Look at that point again. The x-coordinate is -1 to 1. So the domain is -1 to 1. And the range is -pi over 2 to pi over 2. But I have to restrict it like that. Does that part make sense? And I mean, you could restrict it and get a different portion of it, but we want to include the origin in there. So that's where we're going to define it. So it just makes this little like, little squiggly thing.
Oh, the
Okay?
we are going to define it, or is that how?
What's that?
What does that say?
Defined on, and then I have my domain and my range. Okay, now look. Yeah.
So could it be defined from like a different, like not
So,
equal in one, or does it always?
yes, but no. Like we chose this to be it, so that's what it'll always be. Because I want you to get to the origin, basically as close to the origin as you can. Okay, now, what this means, this is where this is really important, guys. What this means is, if the range is only defined from -pi over 2 to pi over 2, what quadrants is sine, inverse sine defined in on the unit circle? 1 and 4. And inverse sine is positive in quadrant 1 and negative in quadrant 4. You guys with me so far? Okay, so let's look at a couple examples real quick. Just like write this down wherever.
Well, sine is positive, but the x-axis is like negative.
Yeah,
And then cosine is the opposite.
not exactly.
Oh no, you're right.
All right. So guys, when I write, what is the inverse sine of 1/2? Now, we have had some questions in calculus where this stuff has come up. You guys have been asked to find the arctangent of 1 on one of your tests, I remember. But this could come up. Let's say we're doing an integral and it comes into an arc sine and I have to evaluate it at 1/2. So you need to know how to do that. What this means is, at what angle does sine equal 1/2? So it's going backwards on your best friend chart, right? So look at your best friend chart, which was where?
So 30?
No. Well, yes, but radians.
Oh, sorry.
Okay? And so I was saying, it said, where is sine 1/2? Just look at your best friend chart. Sine is 1/2 at pi over 6. Okay? Now, here's where this gets really confusing. Okay, great question. Great question. Okay, check it out. So in this case, the answer is pi over 6. Now, that is different than this question. Where does sine theta equal 1/2 on the interval 0 to 2 pi? That's a different question. You're still saying where does sine equal 1/2, But the answers are, well, at pi over 6, and sine is also positive in quadrant 2, 5 pi over 6. So this equation has two answers, but arc sine does not because it's not defined over here. Does that make sense? It's kind of like, I know I've talked to you guys about this before, it's kind of like if I just say, don't write this down, but x is square root of 25, x squared equals 25. How many answers does this have? 1. It's just 5. How many answers does this have? 2, because it's plus or minus 5. Okay? And it's very similar. Arc sine and arc cosine and arc tangent can only have one answer because sine is only positive in quadrant 1. So it has to be pi over 6, and it can't be this one because it's out of the zone. Okay? Yeah, Jake?
When you're solving an integral and an area under curve, you have to use the one and only solution.
Correct. Yep, exactly. Now, see, now this is super tricky, you guys. Inverse sine of negative root 3 over 2. Okay? We know it's at pi over 3. And we know that because it's negative in quadrant 4. Now, we are used to calling that angle, this is what we're used to calling it, 5 pi over 3. Right? But my answer to this is not 5 pi over 3. Why not?
Because
Why isn't my answer 5 pi over 3?
Because it doesn't exist.
Landon.
Is it saying if we go all the way around?
Right, I have to be between negative pi over 2 and pi over 2. Is 5 pi over 3 in that range? No, in fact, 5 pi over 3 goes all the way around like that, and it's coming through an undefined part. So for sine, we have to call it by its negative angle name. So I cannot call it 5 pi over 3. You know what I have to call it? Negative pi over 3. That's what you have to call it. So confusing, right? In a regular trig class, you guys, I spend 1 or 2 days just on inverse trig stuff. So, okay, look. Negative pi over 3. All right? Now, let me show you guys something else.
Math time, bro.
You're acting like Isaac.
Yeah.
Okay, let's say I ask you guys that question. Okay? And I say, where does sine equal negative root 3 over 2 on the interval from 0 to 2 pi? Right? Okay, so you would say to yourself, you would say, self, sine of rad 3 over 2, that happens at pi over 3, right? You would say, self, sine is negative in that quadrant, and so I would call that 4 pi over 3, because that's 1 past pi, and 5 pi over 3, because that's 1 before 2 pi. And that would be my answer, which is quite different than the arc sine answer, because the arc sine answer has to say negative pi over 3. This one's not even there because it's in the bad zone, right? And that one I have to rename it to put it over here. So when I would teach this in a trig class, and I would go through this, I would call this the zombie zone, right? And this is like my analogy. You guys ready for this?
Heck yeah.
I was watching a lot of Walking Dead at the time. I was really into that show. Right? So look, here is Rick Grimes, right? Okay? And Rick needs to go save the day or whatever, right? He's in the Walking Dead, right? But over here, this is the zombie zone. Okay? Rick Grimes needs to go rescue this sad little person down here.
You got it, Rick. You can do it. Why doesn't he just
Right. Would Rick Grimes go like this and go all the way around to come rescue that person?
No.
That'd be nuts. He'd go right through the zombie zone. What is he thinking, right? Rick would just go boop, and pop right down there and help him. Okay? So inverse sine is only here and here. That's it. You guys got it? Okay. Are you ready to move on to inverse tangent? Okay. I gotta erase all of this. Hopefully you jotted some stuff down, or I don't really care if you write it down as long as it's in your brain. All right, here we go.
I wrote it all down.
No, that's good. I mean, I would too, but
I don't have any room now to do this time.
oh, you'll be fine. Just find a blank page somewhere. It's all good.
Blank page.
Okay, here we go. Guys, that's y equals tangent of x, right? My inverse of that would be x equals the tangent of y. Cool, yeah? Okay?
We should not get a 4 in fire.
You like that? Okay. I'm so glad you enjoyed that. Now, that's my inverse. You guys, is this inverse a function? How would I make it a function?
After we know it's not balanced
With y values.
Yeah, and you basically say, I can't have any of these down here or any of these up here. I can only have that one. Okay? And guess what? Check this out. If I do y equals inverse tan of x, make this a big boy, right? It's just that one. Does that make sense? So we have to take away all those other ones, and that's inverse tan. Okay? Now, guys, regular tangent, do you remember where it has asymptotes?
Every 2, right?
So it hits at like pi, 2 pi, 3 pi. Where are the asymptotes? Pi over 2, 3 pi over 2, that's right. So this has asymptotes. Now the pi over 2 and the negative pi over 2 are here. But it's not restricted from negative 1 to 1. It goes negative infinity to infinity. Okay? So here's tangent. Yeah, it's cool. All right, here we go. Inverse tan. My domain is negative infinity to infinity. But my range is negative pi over 2 to pi over 2. Because it turned on its side and it's between those two things. Make sense? Okay? So, what quadrants is inverse tan allowed to live in? What quadrants is inverse tan going to live in? From negative pi over 2 to pi over 2. Quadrant 1 and 4. Same as sine. And it's positive in quadrant 1, it's negative in quadrant 4. And what's this over here?
Zombie zone.
The zombie zone. And so the same thing happens if I happen to be doing an arctan of something that's negative and it's down in quadrant 4, for example, I would not be allowed to call it 11 power 6. What would I have to call it? Negative pi over 6. And I'd not be allowed to call it, you know, what else is in there? 5 pi over 3, I'd have to call it negative pi over 3. Okay, because I can't go through the zombie zone because of the restrictions. Alright? Yes. So I want you guys to try a couple, just jot these down or just see if you would be able to do these.
Probably not.
Get your best friend chart out. Go turn to it. And I want you guys to do those 4 questions. Inverse tan of 1, inverse tan of negative 1, inverse tan of root 3, inverse tan of negative root 3.
Actually, maybe.
This one's not that bad. Let's go. Parker. Parker.
Yeah.
Is Jack here?
Okay, when did I get here?
I know, Parker just got here.
I just didn't do
Clementine here. Anna.
Because I want to pass some stuff.
Connor.
So many people here, that's crazy.
Aiden, I swear I thought I saw Aiden. No,
Facts.
Carly's here. Sadie.
It is. She told me. Today.
What's the when I need to go this way?
I have to pay the AP test.
What do we do to avoid the zombie land? You
Well,
literally
I'm signed up to
Negative angle.
yeah, but how do I?
Like negative power 4, negative power 3, or negative power 6.
Oh, I can just make. So I was right.
Let's go. Maybe, I don't know. Go in here now.
We're not fine, right? We're not fine. Chris is here. Chris is here.
Is that alleyway back there? My eyes are bad. Hi, Ellie. Okay. Brock is here.
You are too.
Yeah. Gabe here? No.
No, we're not.
Annabelle's here.
Paige.
Wyatt's here. What a baller.
Wait, why you
Jason's here. Huh?
Mitchell, Nick, if we play the student council team in the playoffs, are you going to show up again?
Oh, yeah.
Yeah.
I'll try. If I'm not doing anything else.
Okay. So you can watch us beat them by 40 again?
Look, don't be so mean. They're just little guys.
I was only
They're
all
younger.
seniors, and we're all
But
juniors.
they're so little. Is Tess here now? Does they know? Evelyn, no. Lydia, I saw Lydia, no? Lydia, hi Lydia. Henry. Laurel.
I'm so sad.
Harper, no. Annika, I saw Annika way in the back. What's up, homie? Okay, we are chilling. Guys, ready? Oh yeah, I did PC a minute ago. Here. All right, guys, this is asking me, where does tangent equal 1? Well, it's in quadrant 1 and it equals 1 at pi over 4.
What? No.
Guys!
I'm dumb. Yeah.
Oh my heaven's sakes! Is your best friend chart next to you?
Yeah.
Technically, mine is next to that. That's
Fine. Ben,
What?
on your best friend chart,
I don't.
on your best friend chart, we don't use that.
Okay.
Where does tangent equal 1?
Pi over 4.
I literally want to throw something at you.
Do it. Do it.
I know. I'm sorry, I'm dumb.
Brother Manny threw my
I'm also sorry you're dumb because I'm the one that's going to look bad when you don't pass the AP test. All right. Which means that negative is just negative. That's exactly right. And inverse tan of root 3 is pi over 3. So what's inverse tan of negative? Negative pi over 3.
I did get. I got these ones.
Okay. Guys, with inverse sine and inverse tan, the answers are always pi over 6, pi over 4, pi over 3, or negative pi over 6, negative pi over 4, negative pi over 3. Okay? Guess what? Cosine's completely different.
Let's go.
We hate that.
Cosine a little.
If you ever do like a major, like if you have to do a trig class, which hopefully you guys won't have to do a trig class because you should test out of algebra, out of calculus. But if you ever have to do a trig class, it's like sine and tangent follow the same rules, and cosine is always the one that's jacking everything up. All right? Stupid heckin' cosine.
Chris, don't fold. Chris.
Why is that for us?
Oh. He doesn't want those.
All right. All right, guys, look out cool. Y equals cosine x. If I flip it, x equals cosine y. Looks neat, right? Okay. Now, do you guys think I should put this in trig mode? Hang on a sec.
I wonder what the
All right, guys. With cosine, can I restrict cosine the same way I restricted sine and tangent?
No.
No, because then it's not a function. What makes the most sense?
0 to pi.
That makes the most sense. You guys see that? Because it still keeps me in quadrant 1. Okay? It wouldn't make a whole lot of sense to go down here, but that makes sense. So, okay, guys, listen up. I know you're getting antsy, but We're gonna get to some fun stuff. Very well. This is fun. I'm gonna throw a quick shut up.
That's definitely not. That's what I said. I know I'm not a clock, but I know I'm not.
Okay, guys, look. That is the section that we choose for arc cosine to be defined. So let's go through the same ideas, right? Ben,
What?
you couldn't even get sine and tangent. Those are the easy ones. So we gotta focus on cosine.
No. I got tan right. I got tan right.
Popcorn's in her hands.
Or wait, no. I got the. Okay, I got the tan ones right. I got the
Okay.
negative.
So it's still negative 1 to 1, but we said we can't go negative pi over 2 to pi over 2. We have to go 0 to pi. You guys saw that? On here, we had to go 0 to pi. Do you guys see that?
Yes.
What quadrants is arc cosine defined in? 1 and 2, not 1 and 4. Now think about this, guys. Why couldn't inverse cosine be in quadrant 1 and quadrant 4? Why? Because it's positive in quadrant 1 and it's positive in quadrant 4. That doesn't help me. So I got to go 1 and 2 where it's positive, negative. Okay? So cosine is a big pain in the butt. Because cosine is defined in 1 and 2, and with cosine, the zombie zone is down here. Okay? So, Mr. Rick Grimes is never running, that looks like Abraham Lincoln, into the zombie zone. So there are no negative exponents for inverse cosine. Okay?
Let's go.
All right.
Let's go. Let's go.
Oh, please get this right.
Why is it glowing?
I'm gonna get it neutral. I'm a stupid man.
Set of 3 was yours. It was yours.
I hope I don't have volleyball practice.
You're 3.
Wait, it's positive.
Let's get volleyball if I go to another.
Yep.
Just say it for it.
Oh, we have 40 minutes? What?
Yeah, bro, we got so much time. Don't back up. I'll beat you.
Mitchell, you should like bring a sandal just for like threatening.
chamba?
Yeah, just for threatening kids.
That's gonna be used against me like all of these.
That's okay.
Raina, did you see my kid and Johnny Appleseed?
Yeah, the bison. Pretty great.
So cool,
I saw
huh?
your book and
Oh, yeah. I didn't go to that one. I went to the other one.
Yeah.
That's fun.
it was way better than like any play I've ever seen.
It was good.
Except Michael's.
Your brother did the assistant director thing,
And
Raina?
you have MTV Tom.
I watched it better. It was put on better.
But Mikey cakes.
It's Mike's program.
But Mikey cakes.
Huh?
Because it's cosine. But I'm trying to figure out the second one.
What?
Is the second one negative? It can't just be. I know it's not negative pi over.
That, you're making Rick Grimes run into the zombie zone.
Popcorn?
He's trying to rescue his wife, who's right here.
Except for not trying not to.
How is
bully
Rick
you.
trying to get to his wife?
That's Abraham.
You're right.
I remember it. Abraham.
Is it this?
Wait.
Chris, give this to
We go backwards. No, we do
Not the
like,
cosine.
we go like
Chris.
Oh, yeah.
What? So what pages common sense?
Okay.
how long was
No,
that in there?
I don't want it though.
Chris, did you burn it?
I smell
Chris, how long was
Chris, let me see.
I didn't do it. She did it.
Why? Let me see.
Did you burn the popcorn, Chris?
Yes, Chris.
It doesn't look burnt. It smells burnt.
On the inside, in the middle.
Give it to them.
Get it out.
You take it to them.
smell is pervading through the room.
Sorry.
Stop. Use vocabulary.
Pervading through the room.
Okay, you guys ready? Okay.
That smells so
Hey, listen up.
It looks fine.
Chris, gotta take it out. It's gonna make my room smell like burnt popcorn forever.
Just eat it.
Chris, you were demoted to JV first singles, bro.
Okay. Okay, you ready? Where does cosine equal negative root 3 over 2? Where?
Down who's the best on the team?
What?
Who's the best on the team?
Now, if it's negative, it goes to quadrant 2.
You can ask Chris. I'm first.
Guys?
Who's the best? Probably Tyler or
Jeez,
Cass.
that's really bad. You gotta get that out of here, bro.
It's not my problem anymore.
That's facts. I'm better than both Tyler and Cass.
Is it good?
Without a
That's
bracket.
fine. Okay.
Somebody kicked him out of the
Guys,
in there now. Go check.
what do we call pi over 6 in quadrant 2?
5 pi over 6.
That's right. So cosine, arc cosine is the only one that never gives me negative angles for my answer. It doesn't. Okay? Arc cosine of root 2 over 2, pi over 4. What do we call that in quadrant 2? 3 pi over 4. If it was arc sine, I wouldn't call it 3 pi over 4. What would I call it? Negative pi over 4. Okay?
Heads or tails?
Do you guys understand?
Tails means you die.
Alright, so that's everything I can teach you about inverse trig. Now where are we at?
Benjamin, heads or tails?
Yay, finally to the fun stuff. Okay. Are you ready, children? Aye, aye, Captain. Alright.
I can't hear you. Alright, focus. Calculus.
Okay.
Alright, now for me.
Ready?
What's it?
Alright. We want to start solving trig equations. This is something I didn't get to last year, and something I feel like is something I want to go over. It can be very confusing, okay?
Where is this?
Guys,
Never mind.
one way to solve trig equations is just to combine like terms. Like I have a cosine and a cosine, right?
2 cosine equals negative square root.
Yeah, so I could bring this over here and call that 2 cosine, and bring that over there equals negative root 3. And then that's negative root 3 over 2. Right?
Well, we know that.
Okay,
Cosine is x, which means
I
x
added cosine to this side,
Wait, but it's negative 2.
and cosine plus cosine is 2 cosine, right? And I just subtracted the root 3 to that side, and then I divided by 2. Okay, now, I want to tell you guys something. If you are solving this on the interval 0 to 2 pi, okay, you go like this, and you say, first of all, where's cosine negative?
On the bottom.
ASTC.
On the bottom. Oh.
Here and here?
It's on the right side.
It wasn't me, it was
Negative? Where's cosine negative? Okay.
Ours looks so good.
Okay, guys, ready?
Yep.
Where is cosine negative? What quadrants?
Oh, yeah.
2 and 3. Because it goes like this. ASTC. Right? Okay, from your best friend chart. From your best friend chart, where does cosine equal root 3 over 2? Pi over 6. What do we call this one? What do we call this one? 7 pi over 6. Done. This is important. Ready? So on the interval 0 to 2 pi, x would equal 5 pi over 6, 7 pi over 6. In degrees, now this is kind of stupid because it says to do it in degrees. Are we fine if we just don't do anything in degrees? Okay. All right. Now, I need to show you guys this. I'll show you once, then we're not going to really do it anymore. But it says all possible values. So if it said, instead of on the interval from 2 to pi, if it said all possible values, I want to show you guys how to write that, okay? Because it equals it at 5 pi over 6, and then guess what, guys? It equals it at 17 pi over 6. And then it equals again at 29 pi over 6. And it equals it again at 41 pi over 6. How am I keep equaling that over and over again? Right, so it goes like this. It equals it at 5 pi over 6 plus 2k pi is how we write it, where k is any integer. If k is 0, it's 5 pi over 6. If k is 1, it hits it 1 time around. If k is 2, it hits it 2 times around.
What's up with
It also hits it at
square root 3 over 2?
7 pi over 6 plus 2k pi, where k is any integer. Okay, so you just have to add this if it wants all the values. In calculus, we don't do that. We find it on an interval, okay? You try to solve it on an interval.
So why is it like the square root of 3 over 2? That's a weird number, but why does it come out to that? It's like square root of
Because that's how we wrote the equation to have square root of 3 in it.
No, like when you sine a.
Oh, why is it square root of 3 over 2?
Yeah, that's a weird. Especially when using gradients.
That's actually an excellent question. Do I want to take the time to show you?
From pi, and now that random of pi is
Ready?
This one's good.
I actually took this page out of the trig packet.
Outside.
Give me the burnt back.
60s are pi over 3s, right?
yeah.
Give me it.
Drop that down. Right triangle.
Yeah.
Okay? Now, the one I started with was equilateral. So I'm going to call that 1, 1, 1. Okay? Each side is 1. If I drop that down on an equilateral triangle, this side is now 1/2. And if you do a Pythagorean theorem, a squared plus b squared equals c squared. 1 over 4 equals 1. B squared is 3 over 4. B is the square root of 3 over 2, which is that side. Because it's a unit circle, so the pi over 3's will be root 3 over 2, and the pi over 6's, because I cut this in half, will be 1/2.
And such when the sine equals that, the cosine equals that, because really it's just saying one side is that. That's so cool, actually.
And the other one, if you want to know where the root 2 over 2 comes from, it's a 45, 45, 90 triangle.
Oh, I remember this. Yeah, you were teaching us like.
Which is 1, 1, root 2. But if I put it on the unit circle, it actually changes this. If that's 1, that's 1 over root 2, and 1 over root 2, which is root 2. So it goes back to special triangles, actually. Okay, sorry guys, let's keep going. Here we go. That's cool, right? Makes sense? Okay, guys, check it out. Let's try to solve for sine. All right, watch this.
I think I got it.
This one's easy, fun, dubs. Here we go. Add 3, divide by 4. Right? Square root both sides. Now, you guys, when you're solving a trig equation and you square root both sides, what do you get?
Plus or minus.
Plus or minus root 3 over 2. Now, we're just going to do this on the interval from 0 to 2 pi, okay? From 0 to 2 pi. Which quadrants is sine either positive or negative?
1 and 2.
Well, it's positive there, and it's negative there and there, right? So it's all 4. And where is sine root 3 over 2? Pi over 3. Right? So the answer would be pi over 3, 2 pi over 3, because that's pi minus, 4 pi over 3, because that's pi plus, and 5 pi over 3, because that's 2 pi minus. But it's plus or minus, so it's all 4 quadrants.
Is it possible to solve for theta there using inverse sine?
That is what we did.
I mean, it is, but
using inverse sine, that's kind of what we're doing. Like theta is the inverse sine. It's just that inverse sine has problems and it would restrict it, and we have to call it different things. So that's why we're specifically, I would say, on the interval 0 to 2 pi. I have to say that. Okay? Okay, check it out. Guys, wow. You guys know that when I tell you I suck, that you suck, I'm just mostly joking, right? You guys suck at factoring, yeah?
Yeah.
All right, now we're going to factor with trig functions. So if I didn't already want to bang my head against the wall, now I have to teach you factoring with trig functions. Guys, GCF, what can you take out of both terms?
Cos theta.
Cosine theta, and what are you left with? Now, once you factor, what do we always do once we factor to solve for 0, or to set it equal to 0? What do we always do? Both parts equal to 0, right? Cosine theta.
Also, when sine is 1/2.
And then 2 sine theta minus 1 is 0. Add 1 and divide by 2.
At pi over 6.
So I am trying to figure out where cosine is 0 and sine is 1/2 on the interval 0 to 2 pi. Okay?
6 is one of them, right?
Let's start with cosine 0. Here's how I would do this if I didn't have my best friend chart in front of me or whatever. I'd be like, okay, that's 1, 0, 0, 1, negative 1, 0, 0, negative 1, cosine, comma, sine. Guys, where's cosine 0?
Pi over 2 or 3 pi over 2.
Very good. So I have those two solutions. Then I come over here. Where's sine a half on your best friend chart? Pi over 6. And that's a positive. So what other quadrant would I look in?
2.
AS. And in quadrant 2, pi over 6 is called?
Over 6.
And those are my solutions. Does that make sense? Solving trig equations is like one of the funnest things, I think.
No, it's not.
Because you factor, you set it equal to 0, and then it always works out to these really cool things, and then you solve it,
I don't
right?
think any of those steps are better.
Oh yeah. Okay, look, this one's fun. Ready? Guys, if you can factor that, which let's be honest with you, most of you can't. If you can factor that, you can factor that. Okay?
And you take out a sign.
No.
So you know,
Oh, that was
How do you factor this? Do you guys remember we would go like 2x times x, 1 times 1, outside, inside? Remember? Factor.
Coons was awful. I don't
She
think
laughed at me because I didn't know how to factor. So.
Yeah.
Well,
She didn't
And it
teach us
didn't teach me.
anything.
I don't laugh, I just call you stupid, but. Alright.
But at least you show us after.
At least you
All right.
teach us how to.
Chris, ready? This is for you and all your fellow people that didn't have me last year. Rip to you guys. You guys ready? Here's how you factor a trinomial, okay? Go like this. Look at the first term. It's kind of like FOIL, but it's backwards FOIL. What multiplies to make 2x squared? 2x and x.
Yes.
Yeah?
Yeah.
Okay. Sometimes there's choices. This one there's not really a choice. What multiplies to make 1?
1 and 1.
1 and 1. Now, what has to happen is the outside and the inside has to equal that. Okay? So the outside is, what's 2x times 1? 2x. The inside is 1 times x. 1x. And can I get negative 3 out of that?
No.
2x and 1x?
Yeah.
Yeah, I can if they're both negative, right? Negative 2 and negative 1 equals negative 3. Okay? Which means that then I go back to here and I go, okay, that has to say negative 1x, so that's negative. And that has to say negative 2x, so that's negative. And that's my answer. And that's how I factor.
That was way easier than what she thought.
Okay? Now, guess what? I factor this the same way. Okay, so check it out. Can you guys at least see the pattern that it's a trinomial?
Yeah.
It's got like a sine squared, and then a sine, and then a number. What multiplies to make 2 sine squared? 2 sine times 1 sine. Yeah?
I would not have seen that. I would have done something different.
Yeah, it's because, well, and you can't factor out a sine because you can't take anything out of it.
I'd subtract them.
So that's the big, yeah, you don't have to do that. Because it has to stay equals to 0.
I mean,
Okay, hold on a second, guys.
give me some paper.
Can I make fun of you for a second?
Yeah.
All right. Check it out. Guys, this is what Dallin wants to do. Dallin wants to do this. He wants to bring the 1 over. I know this is what he wants to do. And he wants to take out a sign.
Idiot.
That's fair.
I know. It's
Right? And then Dallin wants to say, okay, well that means sine is negative 1 and 2 sine x minus 3.
No, that's
is
not what I
negative.
want. Well,
That's
yeah.
That is what you want to do. Now, where is this whole process breaking down?
because if you multiply one by negative 1, the other will be a different number.
Yeah. The only reason that we can factor and do this is a little something called the zero property of multiplication. And the zero property of multiplication says if it equals 0, that one has to be 0 or that one has to be 0. That is not true for any other number.
Wait, oh yeah, that, I get it.
Right? Because like, let's say this was 5. If I have 2 things that multiply to make 5, does one of them have to be 5?
I know. You
No,
do it every
right?
day.
Oh yeah, zeros are an evil virus and they
You
take
asked-
over the numbers. They do.
Thank you for letting me use you for an
I
example.
was like,
You weren't the
what
only one that
the
thought
hell
that.
is this?
Alright.
Oh, I just ignored
So
that.
guys, when we're factoring, there has to be a 0 right here because of the 0 property of multiplication. Okay? It is. All right, now check it out. What? Hold on. What multiplies to make 1?
C property of why not states that C can eat every other number because all of it's just a constant.
That's exactly true. Okay, so look.
they're both going to be negative.
2 sine x.
They're both negative.
1 sine x. Can I get negative 3 sine x out of that? Negative, negative.
That's crazy.
Now, because of the 0 property of multiplication, I say either that one could be 0 or that one could be 0. Because if one of them is 0, it's going to be the other one. Go for it. Euclid did that, and then he called it Euclidean geometry.
And then you
Called
get
like
weird
Dalinian geometry.
I have to ignore you until
Yeah, but his math was cool. And it made sense. He grabbed like a spear and did that.
I don't know what happens.
Can you guys solve this on the interval 0 to 2 pi? You guys solve that?
No.
There are 2 spots where sine equals 1. There's 1 spot. Sorry, there's 2 spots where that works. There's 1 spot where that works. See if you guys can find it. Ready, set, go. Alan.
What are we doing?
You're solving that. There are 2 values for this one and 1 value for that one.
I don't even.
5 or 6, 5, 5.
I don't know what I'm looking at.
And then for when sine equals 1, I don't really remember what cares.
Wow.
But I got the left one. That's what matters.
It's a dot that counts, right?
When does
I'm
sine
giving it
equal
another
1?
dot.
Oh, I'm so stupid.
It's not for popcorn.
I forgot what the sine equals.
Okay, where's sine of half?
5 pi over 6 or pi over 6.
Oh, not 1.
And where does sine equal 1?
Pi over 2. I'm stupid and I forgot that.
Yep, pi over 2. Down the street.
I got it.
It's like Dallin just flips
All right.
a coin and he's either like the smart
I
person
don't think you would see this on your AP test, but let's look at number 5 real quick, okay?
Then you got Steven.
Here is the problem, my friends. I can't solve something with a secant squared and a tangent squared in it. They have to, at least if I want to factor it, they have to either all be secant squareds or all be tangent squareds, right? Let's look back into the recesses of our brain and about an hour and 15 minutes ago. Did I tell you an identity that related secant squared and tangent squared?
Yeah.
What was it?
I can't remember.
Okay, well, I can't remember it either, so, and I'm being serious, I don't remember.
Oh, it's this one.
It's sine squared plus cosine squared is 1, so how do I change it to tangents and secants? What do I divide everything by?
You divide by cosine.
Because then tangent squared plus 1 is secant squared.
So we just pick one and swap them out.
So pick one and swap it out. So I'll pick the secant squared, and I'll swap that out with tangent squared plus 1. Does that make sense?
Usually you want to set that. Distribute the 3 out.
Yep.
We just chop
Distribute the 3.
And then we just get a negative 1 and tangent squared.
Breaks down.
How we doing so far? We good?
No.
Distribute the 3.
Oh, but then you can add 1 over actually.
Hey, Delano.
Delano?
Help us road. Now, I switched from thetas to x's in the middle of the problems. What am I even doing?
Bro, that's so
Okay, 3 minus 2 would be 1 tangent squared, and 3 minus 4 would be negative 1. There are 2 ways to solve this.
You need to slow down.
Yeah, there are 2 ways to solve this. Add 1 and do what? Add 1 and square root. That's one way to solve it. There's another way to solve it. What is it?
Love you, Mitchell.
Love you, buddy.
Oh, there's another.
No way this guy just gave me grab treats in the
Oh, we don't actually.
Delano? It's fine, because the couches. Nothing. Get out of here.
You're a counselor.
Okay.
He thinks your kid isn't it?
Yes. You guys, the other way is factor difference of squares. right?
Ooh, let's do that.
If you do difference of squares, it's tan plus 1, tan minus 1. Okay? Same thing though, right?
Oh yeah, it's still if plus or minus.
So either way, I get tangent squared is 1, square root it. Tangent is plus or minus 1, my friends. What quadrants does tangent equal either a positive or a negative?
Positive.
All of them, right? Because it's positive in 1 and 3, and it's negative in 2 and 4, and it's a plus or minus.
I'm in denial about a lot
Right?
of things. Abby,
And what angle does tangent equal 1? What radian?
take me now.
Very good. So the answer would be pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4.
Or we could just.
Oh my gosh, I'm so
Plus or
dumb.
minus pi over 4, plus or minus 3.
I'm jumping out the window.
That window
On the interval 0 to 2 pi. Well, I don't know. Okay, I want to skip that one. It's fun, but I want to skip it. I'm going to skip multiple angles, but I'm going to do this one, and we're not going to use a calculator.
Why just say calculator?
Hey Mitchell, I gotta go to work now.
Okay, kid, you're good.
Doc, quit your job for calculus. You could get another 10 minutes of studying.
Challenge you with AirPod in your half hour.
Bye, Zach. Okay.
I took a nap in medical anatomy.
Bye, Zach. Love you. Guys,
Woke up, already had
this is...
I don't think it's working. What?
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 This is for all of you suckers that still don't know how to freaking factor. Now, step 1, I had to bring the 6 over. Let's ask Dallin why we had to bring the 6 over.
Because zeros are a deadly virus and eat other numbers.
Because it has to be a 0 on this side because it doesn't work unless it's a 0 because... Okay, fair enough, guys? Okay, now, start over here. And I'm going to tell you guys, we're going to do it probably a couple of times, guess and check until we figure it out, okay? So start with that. Now, there are 2 options.
Wait, why don't we just leave the 6 there and take the tangent out?
Right, so this is what I was making fun of Dallin for. I make fun of you for it too. Okay, check it out. Leave the 6 there, take a tangent out, right? And this would say 4 tan theta plus 5 equals 6.
Yeah.
And then you want to say, okay, so that means tangent equals 6, and 4 tangent theta plus 5 equals 6. That's incorrect. The only time we can do this is when that's a 0. Because otherwise you're saying something, what you're saying is if something times something equals 6, one of them has to be 6. That's not true, right? Because this could be 2 times 3.
Right.
You know? So it only works for 0 because if 2 things multiply to make 0, then one of them has to be 0. Okay? So you cannot factor unless it says equals 0. Here we go. Do you guys want to try 2 and 2 or 4 and 1?
2 and 2.
Let's try 2 and 2. 2 tangent and 2 tangent. Okay, now come over here. We could try 1 and 6 or 2 and 3. What do you guys want to try?
2 and 3.
Cool. Okay, ready?
Yep.
Outside gives me 6 tangent, inside gives me 4 tangent. Can I get 5 out of that? No. So it's not 2 and 3.
I told you.
Okay, so let's try 1 and 6. Outside gives me 12, inside gives me 2. Can I get 5 out of that? No. So what about if I do 6 and 1?
There we go. Wait, why is it?
It's the same thing, buddy. It's a 2 and a 2 in the front. Okay? It's 2 tangent on the outside, 12 on the inside. We still can't get it. So what does that mean? It doesn't factor?
No.
It means it wasn't 2 times 2. So now we're going to go back and try...
Can we also try like completing the square to get the last digit to change?
Not with a number in front. That would be ridiculous. Because you'd have to factor out a 4 and you get 5 fourths, and then you'd have to do half of that.
We wouldn't have to factor the 4 if we changed it as well.
Okay, guys, did we find something? 3 and 2, because the outside is what? 4 times 2? 8. That's what I thought. And the inside is
Oh, that
3.
works.
And how do I get 5
Plus 3 minus 2.
plus 8 minus 3 plus 8 minus 3? Am I done with this problem yet?
No.
4 tan equals minus 3 equals 0. Tan plus 2 equals 0, which means
So we just
where does tangent equal 3/4 and where does tangent equal -2? And you can't solve that without a calculator, so then you just go on your calculator. Okay? You can't solve those without a calculator unless it's one of your chart angles.
Well, then, couldn't I just plug the beginning thing in? The 4 tan squared plus 5 tan plus 3 minus 6, and then my calculator.
Yeah, but then we couldn't have factored it. In fact,
What? I'll take a
What's
picture
wrong
of
with
the
you?
armor.
I'm lazy.
We have a boomerang on the side of the wall. It's China history.
Yes, they are. That's so laziest people.
Sure.
What was the second answer?
That's
Wait, Schmidt.
So after that, I would have to go to a calculator, and I'd have to find it, because to find out where tangent of theta is 3/4, it's not a chart angle. So on your calculator, you would type, what's the inverse tan of 3/4?
Yes.
What's the inverse tan of -2? And you can find it.
Okay, so this sounds like a weird question, but like, why? What is 0? Like, how come 0 have, like, 0 and 1 always have these
Hey,
really special
you like
properties?
research?
Like, they're special.
I don't remember if it was Greco-Roman times, but the concept of 0 didn't exist yet. And so the secret math meeting of people that were discussing like 0 as a thing, and other people were like, no, and they would like get killed over it. Go research
Like
that.
0, it's like a weird number.
Okay.
0 doesn't exist.
If you guys can do,
But like 0 divided by something, well, I guess it actually makes sense.
if you guys can do that question, we'll be done.
And like 0 factorial is 1, which actually makes sense. It'll just be 1.
And anything with a 0 is 1, which makes sense for this little shady thing. Does that go for equal 0?
Paige. I'm just too scared to get me a sister.
I do.
Why would you say Why would you tell me to share that?
I don't know if you guys remember this, but during class yesterday or this morning, during class this morning,
0 was discovered after looking at my bank account after
now, during class this morning, I put that on the board and I said, if you can't solve that, you should come to today's review session. And now I think you can solve it. I think. No, so my hand.
I just
No one can
out of the
I mean, it's gonna screw you up. No.
I know a little bit.
It's x squared plus x
Right.
minus 1.
So I think that you can do that now after 2 hours of trig with me. I think you can do it. Let's see.
I might be able to.
I think you can.
We got a 2x plus x minus 1. We use the
Bro,
double
I don't understand because it's not hard and yet nobody can do it.
There's just not hard for someone like me to like derive.
Alright, so 2x, we get that thing from an x and an x. Oh, it's a 2x squared. That's what we do.
Say yeah.
That's like 2x.
Switch your plus and minus. So guys, what goes first? What times what? What goes second?
I'm gonna just
Right?
guess. Can I just guess?
No.
How
Guess
is it so
2x
easy
minus
though?
1
You
and
just
x
have to
plus
figure out
1.
the multiply.
Might get the trick.
I think that's just
I actually, no, because if I apply half,
Does it have to be in that order?
No, but the minus has to be with the 2 sign there.
Oh.
That's what I guessed.
That's so silly.
My instincts told
You
me.
had a 50-50 chance.
Well, my instincts told me there's like a -1 there, so we know something's got to be negative. And it just ones and stuff, so we know it just.
Okay, so how do I know that this is it? Well, I went outside, which was 2, inside, which was 1.
Oh.
2 minus 1 is 1. So that had to be minus, that had to be plus. Okay?
Fair enough.
You get good. If you really want to get good at this, I can assign you 100 delta math problems on just doing that. We'll see how good you can
Would
get.
that be extra credit?
Wait, did you do the AP questions?
You should do that as extra credit.
Okay, now, when I set those both equal to 0, I I'm finding where does sine equal a half, where does sine equal negative 1?
Sine equals negative 1, 3 pi over 2.
Pi over 6.
And then negative 5.
And what other quadrant? Quadrant 2.
You could say
5 pi over
negative 1,
6.
but it's negative pi over 2 or 3 pi over 2.
Are you guys impressed with yourselves? I'm impressed with you. Alright? You guys don't have to turn anything in. Everybody gets points for being here. Good job. We gotta save our snacks for the next time, and I'll replenish what we ate a lot of. Clearly I need more fruit snacks.
Mitch, I don't think you understand how many I need.
That's not even your pencil, bro. Oh, I thought you were talking about my yellow one.
Oh, nothing. I can't solve that.
At least you got it.
My dad can use
I can basketball game with you. I'm kind of excited for it. I should just keep trying out what it's not doing.
Alright, peace out, friends.